होंगे कामयाब, होंगे कामयाब, हम होंगे कामयाब एक दिन। हो मन में है विश्वास, पूरा है विश्वास, हम होंगे कामयाब एक दिन। होगी शांति चारों ओर, होगी शांति चारों ओर, होगी शांति चारों ओर एक दिन। हो मन में है विश्वास, पूरा है विश्वास, होगी शांति चारों ओर एक दिन।
Dear students, you will be given a very important exam of your school life from April 2021. Due to corona pandemic, this year was challenging for you all in terms of offline teaching and learning process. In spite of that, most of you are able to complete your portion. So for this, we really want to appreciate your hard work. Still, we feel that some students are not assured and confident whether they have completed their studies or not. They seem to be very confused. In order to help such students, Gyan channel has started a series for providing helping hand to our children. In this series, we are going to solve all your queries related to Science-1 and Science-2 to make you feel confident by solving all your queries and by clearing all your confusion. So today, I will be discussing one of the chapters from Science-1. Before that, let me discuss some important points. Let us share the screen. Asim Dhyan Vahini, Unlimited Knowledge, SSC at one glance, a complete guidance series. Concept, direction and coordination by Mr. B.B. Jadhav. Myself, Shama Tiwari, MSc BA from St. George High School, Kurar Village, Malad East. I will be doing with you Chapter 6 from Science-1 textbook, Refraction of Light. Before I discuss with you the concept related to refraction of light, I want to tell you once I am teaching you, you all please make a note of all the topics, whatever will be discussed with you. And these topics are very important and they are expected topic to be asked in the board paper. If you study only this topic, I assure you, you will definitely get flying marks in Science-1 SSC board exam. So before I start, I would like to introduce you the paper pattern of Science-1 and Science-2. Because of this, which type of questions will be asked in exam, you will be clarifying and which will be enabling you, all students, to study as per the paper pattern. So let us start. Science-1 paper pattern, there are total 4 questions. Question 1 is divided into 2 parts. Question 1A, multiple choice question based only on the textbook. Each question 1 marks. Each question carries 1 marks and it is only from the textbook the questions will be asked. Question 1B, again 5 questions. Each carries 1 mark, but there will be no filling the blanks question. Correlation term, match the column, odd one out, true and false, all such type of questions can be asked in question 1B. Question 2, again divided into 2 parts. Question 2A, give scientific reason, questions will be there. There will be total 3 questions. You have to answer any 2. Each question carries 2 marks. Question 2B, writing short any 3 out of total 5 questions. In that, define the following, distinguish between, explain the term, identify the diagram. Like that, each question carries 2 marks. So the total marks for question 2 is of 10 marks. Question 3, answer the following. Out of total 8 questions, you have to attempt 5. Each question carries 3 marks. In this, complete the paragraph, distinguish between, explain the phenomena, explain the term, draw neat and able diagram, etc. Questions will be asked. Question 4. Answer any one out of two. Out of total 2 questions, you have to answer any one. 1 mark question carries 5 marks. So the total marks for Science 1 is 40. Now I'm going to discuss the important concepts from a refraction of light chapter. Whatever I will be narrating you, make sure you all listen it carefully and study this topic thoroughly, as these are some of the highly expected topics to be asked for your board exam. If you memorize and understand these points and topic thoroughly, we assure you that you all will get well prepared for your SSC examination in advance. So let's start. Children, as you can see, there are 2 beakers. In the 2 beakers, there are 2 pencils. One pencil is kept in the beaker at 90-degree angle. The other pencil is kept in the beaker containing water at some angle. In both the beakers, the portion of the pencil which is dipped inside the water is appearing little thicker. In the second case, the portion where the 2 media are separating, the surface separating the 2 media, the pencil appears to be broken. Why it is so? That we will study in this chapter. It is due to refraction of light. Children, you can see there is a glass slab. When the light splash on the glass slab, the light should travel, expected to travel straight. But instead of traveling straight, it travels in little bend or in different direction. It is expected to travel straight like this, because light always travel in a straight direction. But instead of traveling straight, the light changes its direction when it enters from air medium to the glass medium. This is known as refraction of the light. Same light, when from the glass medium, it coming out again to the air medium, the light is expected to travel straight like this, but it is not traveling straight. It again changes its direction. This process where the light changes its direction when travels from one transparent medium to another transparent medium is known as refraction of light. For that, let us go through the example. Refraction of the light passing through a glass slab. Children, you can see this is a glass slab. This is acting as one medium. Outside the glass, there is another medium, air. So when one of the ray of the light incident on the glass slab, so this ray is AB, which is incident at N. Now, there is an angle formed between incident ray and the normal, which is known as angle of incidence. This is angle of incidence. The light is expected to travel in this dotted line, the dotted blue line, that is straight line. But once it enters the denser medium, which is nothing but the glass medium, the speed of the light is reduced. Instead, the angle of incidence was I, that is greater, but when you see here, the angle of refraction seems to be lesser. This is due to the less speed of light. The speed of light in the glass medium is reduced and its direction changes, or you can say the light bends towards normal. When the same blue light, that is a refracted ray, now acting as an incident ray and comes out of the glass slab into the air medium, what happens? It is expected to travel straight like this. But now the light is entering from a denser medium to rarer medium, its speed of light increases. Again, you will see the angle of emergence between the normal and the emergent ray is bigger compared to the angle of refraction. This all happens due to refraction of light. Laws of refraction, there are mainly 2 laws of refraction. The first law says the incident ray, the refracted ray, the normal to the surface, separating the 2 media, this is air and inside water or glass, separating the 2 media, at the point of incidence, all lie in one plane. So I'll repeat it. the incident ray, the refracted ray, the normal to the surface separating the two media at the point of incidence all lie in the same plane. What does the second law states? The ratio of the sine of angle of incidence. Suppose this is angle I, this is angle R. When we take the ratio of sine of angle I to this angle of R at any point on the surface, it will be always constant. This is the second law, which is also known as Snell's law. So the ratio of sine of angle of incidence to the sine of angle of refraction is constant for a given pair of media. This is the second law, is also known as Snell's law. Now, refractive index. As we have studied, the direction of the light changes when it travels from one medium to another. So it is different in different media. It is known as, or it is related to the refractive index of the medium. As you can see, there are many different substances: air, ice, water, alcohol, kerosene. All are having different refractive index. When we see in terms of their density, the refractive index of the denser medium, like kerosene, is more compared to the air medium. Okay, so refractive index increases with density. The value of refractive index is different for different media and also different for light of different colors of the same medium. The refractive index, or plural of index indices of some substance with respect to the vacuum, is given in the table. Now there are certain rules. The refractive index depends on the velocity of light in the medium. As I told you, the velocity of the light in denser medium will be less compared to the velocity of light in the rarer medium. So let us see. The refractive index of the medium with respect to vacuum. If one of the medium is vacuum, then such refractive index is termed to be absolute refractive index. Now there are rules. Let us learn the first rule of refraction of light in different media. The first rule says, when the light ray, this is light ray, is passing from rarer, air is a rarer because it is less dense medium, to the denser medium like glass, it will bend towards normal. Why it is bending towards? Instead of traveling straight, it is bending towards normal. The reason, the speed of light in the denser medium decreases. So what is the rule? When a light ray passes from one rarer medium to the denser medium, it bends towards normal. Rule number 2. When the light passes from denser medium to rarer medium, it bends away from the normal. This is incident ray. As expected, it should travel straight. But when it enters rarer medium, it is less dense medium. So it will bend little away from normal. So this is the rule number 2. In this example, the denser medium is taken glass. The speed of light in glass is less compared to the speed of light in air. Rule number 3. When the light ray is incident normally at the boundary between two media, it does not change its direction, hence does not get refracted. Just remember the slide 1, what I showed you related to the refraction of light of the two glass beakers where pencil was dipped. In the first beaker, the pencil was not seen broken at the surface separating the two media. This is the reason, because it is not seen changing its direction. This is the case when light, incident light, is kept at 90-degree angle to the surface. Then the refraction light will be also at 90 without any change in its direction. Twinkling of the stars. Twinkle, twinkle, little stars, how I wonder what you are. Yes, we are learning this poem since our childhood, but we should know the reason behind it. Why stars twinkle? As we all know, stars are very far away. Suppose the star is here. The space surrounding the star is rarer medium. It is rarer medium. So when the light ray enters from the rarer medium to the envelope, the atmospheric envelope of the Earth, which is acting as a denser, the light ray will bend towards normal. Not only it is bending towards normal, but what else is happening? You can see it is bending towards normal, but since the atmosphere is consisting of moving pockets of cold and warm air, sometimes bending towards normal, sometimes away from normal. And because of this reason, they appear to be twinkling. So let us know the points related to the give reason why stars twinkle. First point, self-luminous. Stars are self-luminous body, means they have their own light. Second point, they appear as point sources because they are very far away. So they appear as a small point source objects. Since because of the large distance from us, the density of air increases. As I told you, the star, it's a hot body. So the surface surrounding the star is acting as a rarer. So what we can understand, hotter body acting as a rarer medium. So when it enters to the envelope of the air, which is acting as a denser medium, so the density of air increases. When the density of air increases, starlight travels rarer to denser, will bend towards normal, and it constantly bends. Refractive index also increases. So we can understand one more point. More denser medium, more is the refractive index. And motion of atmospheric air consists of pockets of cold and warm air. So changing air density and temperature, that the position and the brightness of star keep changing continuously, and the star appears to be twinkling. Planets do not twinkle. The reason is very simple. First of all, planets are very close to us. They appear as collection of point sources because changes in the atmospheric refractive index position as well as the brightness of individual point source changes. But the average, when it is taken, the average position and the total average brightness, it remains unchanged because closeness to the Earth's surface. So they do not appear to be twinkling. Second reason, they are close to us. First reason was they are extended source, they are no more point sources, they are close to us, and they do not have their own light, they are non-luminous objects. Next one, early sunrise and delayed sunset. What does it mean? By sunrise, we mean appearance of the sun above the horizon. Horizon is the place where the earth, the land and the sea, or you can see the sky and the land meets. When the sun is below the horizon, we are not able to see it. But when the sun comes above the horizon, we are able to see. But then how come we are able to see the early sunrise? When the sun is somewhat below the horizon, the light rays are able to reach us along a curved path due to their refraction. Through Earth's atmosphere, apparent position of the sun. Exactly the same process also happens during the sunset. So let me show you through the proper diagram. Suppose we are standing, this is the Earth and we are standing here. The actual position of the sun is here. Now what happened? The space surrounding the sun, as I told you in case of the star, it is rarer medium. When it enters these circles are nothing but they are envelopes of atmospheric envelopes of Earth's atmosphere. So when from rarer medium, the light ray enters the different envelopes, it reaches our eyes from rarer to denser. When it enters, it is bending towards normal. And when it finally reaches to our eye, it is reaching along a curved path. But our brain doesn't take it in a curved path. Our brain always interprets the light in a straight angle. So we see the stars somewhat here, which is much before than actually it was. So this is the actual position, or you can say real position, but it is below the horizon. But we are seeing much before the actual sunrise has taken place, the sun here. This is known as early sunrise, and the position of the star at that point is known as apparent position of the star. Same reason you can give for delayed sunset. So early sunrise takes place when calculated 2 minutes earlier the sun rises and 2 minutes later the sun sets. We'll move to the next slide. Dispersion of the light. We are very fond of bringing from the scale the different 7 colors, as you all are very fond of. Same principle happens here. When we take a glass prism, white light, which is also known as polychromatic light. Polychromatic means it is made up of different colors, but these colors are not visible to us. When this light, white light, enters the glass prism, it bends at different angles. And when finally it comes out from the glass to the air medium, from denser to the rarer medium, the dispersion from the white light to the different colors takes place. You can see the different light, different colored light has bent to the different angles. As we know, white light is electromagnetic radiation. The visible wavelength of this radiation is 400 to 700 nanometer. Visible means which we are able to see. Only through this wavelength we are able to see the light when the objects are falling under this wavelength. Now what we can understand, in this case, the violet light has bent the most. Red light has bent the least. So the maximum wavelength, if it is bending the least, it can travel long distance. So the maximum wavelength is 700 nanometer, and that also for red light. That is why most of the danger signal is made up of red color, because the red light can travel larger distance and we can see from large point of view. It is the maximum wavelength is for red light, and it is lowest refractive index and acting as a rarer compared to the violet, which is highest refractive index, considered as a denser with the smallest wavelength of 400 nanometer. Now, we can learn the definition now. The process of separation of light, or more precisely, you can say white light, into its component colors while passing through a medium is called dispersion of light. Now, we'll study the next important topic, partial and total internal reflection. You can see this picture. This is inside is a denser medium. Suppose I keep a torch light here. Or take an example of a fish tank. Inside the fish tank, if a bulb is fitted. So when there are different incident light will be getting incident on the surface separating the two media. Suppose this is incident ray and it is getting incident at 90 degree. As we have studied, there will be no change in the refraction angle. When now this incident ray is making an angle I here. So angle of refraction when it comes out of the denser medium glass to the rarer medium air, the angle of reflection you can see it is larger compared to the incident because the light ray will bend away from the normal. But you can see there are few arrows which are going inside the water vat or inside the glass vat. What is that known as? They are the partial reflected light. So one is the incident light getting refracted due to refraction when the light travels from denser to rarer. And again, it is also getting partially reflected inside the glass. When I keep on increasing, angle of incident here this much. When I keep on increasing the angle of incident, now the angle of incident compared to the first angle of incident is larger. So then angle of refraction also increasing. At a point comes when the angle of refraction almost becomes 90 degree. That part, the angle of incident is termed to be critical angle IC. After this critical angle, if you further increase angle of incidence, there will be no angle of refraction. After that, only reflection will take place. This is known as total internal reflection. There are two conditions for total internal reflection. The incident ray must be in optically denser medium, like example glass here. The angle of incidence in the denser medium must be greater than the critical angle of pair of the media in contact. So these two important conditions should be there for total internal reflection. Rainbow is a beautiful natural phenomena. How does it occur? You can see the raindrops are acting as a small prism. So when sunlight enters, refraction happens. Now the sunlight entering here, the refracted light, again when it comes out from the water drop to the air medium, the total internal reflection also occurs. And when finally it comes out, from one medium, that is from denser medium water to the rarer medium, dispersion of light also occurs. So actually rainbow is a combined effect of dispersion, refraction, and total internal reflection of light. It can be seen mainly after a rainfall. Small droplets of water act as a small prism. As we have covered the important points topic from this chapter, so let's focus on the question based on the previous year's board paper based on this chapter. So both questions of previous year. A ray of light makes an angle 50 degrees with the surface of the glass slab. Its angle of incidence will be dash. Multiple choice question which was asked in 2019 March SSC exam. Second question, what is refraction of light? Draw the diagram of refraction of light in the glass slab. Write the laws of refraction. This question was asked for 5 marks in SSC March 2018. Question, when a ray of light travels from air to the glass slab and strike the surface of separation at 90 degrees, then it dash. So you have to find out the correct answer from MCQ, SSC March 2016, again 1 mark. Observe the following figure and answer the questions given under it. So figure-based question, SSC March 2017, it was asked for 5 mark question. Students, we have covered most of the important points from this chapter. In exams, question will be asked only on this covered part. So in order to evaluate your learning, I'm going to conduct your oral test or quiz in quiz format. You will get one question on your screen for which you will be given 10 seconds to think about the answer and to write the answer on a piece of paper. Once the given time is over, the correct answer will be displayed on your screen. Tally your answer with the answer on your screen. With a small quiz, you will be able to evaluate yourself properly. So, students, let's start with our quiz. Fill in the blanks. When light travels from one transparent medium to another, changes its direction. This is called dash, and time starts now. Yes, children, it's refraction. Second question. The phenomena of splitting of light into its component color is called dash. Your time starts now. Yes, you all are correct. Dispersion. Third question. The total internal reflection occurs when angle of incidence is dash. Your time starts now. Yes, children, it's correct. Greater than 90 degrees. The range of visible radiation is dash, and your time starts. Yes, children, it is 400 to 700 nanometer. The refractive index of a medium with respect to vacuum is called its dash. The time starts now. Yes, absolute refractive index. Let us move to the next section. State whether the given statement is true or false. Starlight travels rarer medium to denser medium, constantly bend towards normal. And your time starts. Yes, children, you all are correct. It's true statement. Second, for a given pair of media, the ratio of the sine of angle of incident to the sine of angle of refraction changes. Your time starts now. Yes, it is correct. It's a false statement. When a ray of light is incident normal to the interface between any two media, it's get deviated. Your time starts now. Yes, it's correct. It's a false statement. Band of different color is called dispersion. Your time starts now. Yes, students, it's correct. It's a false statement. The next true and false, we observe early sunrise with a time of 2 minutes. Your time starts now. Yes. So it is true statement. Let us move to the next section. Name the following. Celestial body which behave as extended source of light, thus do not twinkle. Your time starts now. Yes, it is planet. The next question. The term used for the ratio of the sine of angle of incidence to the sine of angle of refraction. Your time starts now. It's true. Snell's law. The color of white light which has maximum wavelength. Your time starts now. It's correct. It's red light. The name the prism used naturally during the formation of the rainbow. Your time starts now. Yes, it are water droplets. Okay, children, we have come to the end of this program. With this, we have come to the end of this chapter, Refraction of Light. If you feel this video is useful to you, then do like, share and subscribe because you will be able to get all the episodes of this series on your channel, which will be fruitful for you as we are going to provide important and valuable guidance. Also, if you have any doubts, queries about any concept or topic, feel free to leave a comment in our comment box and we assure to solve your all doubts. Be confident, be meritorious and achieve glory. Thank you and all the best for your SSC examination.